So what our definition of a log enables us to do is to convert from the log of a number into expressing the number as with a base and a power. So that's one common thing that you do within logs, and the other common thing that you'll do is to evaluate the log. So you'll actually be finding the power yourself. Now, basically, you could use a calculator for some, or it's not necessary to use a calculator in all cases, nor is the calculator able to be used in all cases. So the calculator is good, but only for two particular bases. One is base 10, so it's 10 to particular powers, and the other one is a special number called e. We're yet to see what is so special about this number e, and we won't see that until after we've started calculus. However, e is approximately, e is a number. It's approximately 2.718. And you're able to use a calculator to access the log of numbers to base e, this base 2.718. On your calculator, it's indicated with an LN, and I'll talk more about that when we're actually doing a question. So there are two log keys. There is just the straight out log, L-O-G key, and the understanding there is the base is 10. There's a second key with an LN on it, which is log to this base E. So if we have to base 5 or to base 2 or to base 7, we don't have the provision on the calculator to evaluate those situations. So we've got to have some other methods of evaluating. Now, like I said, it's not necessary in some cases to go to a calculator if you know some common powers. Then certainly if you know the powers of 2, then it becomes very easy to find the log of numbers to base 2. Let's quickly do that. So 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the minus 1 is a half, 2 to the minus 2 is 1 over 4, and let's stop there. So if I was asked to evaluate the log of 4 to base 2, now remember, not possible on a calculator. Only ones that are possible on the calculator are this E and 10. But if I understand what that means, what I know I'm looking for is 2 to what power gives 4? And I know the answer is 2. Likewise, here we could have log of 8 to base 2. And I'm looking for the power that 2 needs to be raised to in order to give 8, and that's 3. Again, I could take the log of 16 this time to base 2, and the answer will be 4. So I'm getting these because I know some common powers is the way I've described it. Some base 2 to its common powers. You will commonly see numbers like 4, 8, 16, especially when we've got base 2. A half is a little bit of a sort of hidden base of 2, so we could be asked to get the log of a half to base 2, and you can see that is minus 1. Or you could be asked to get the log of a quarter to base 2, and you can see the answer is minus 2. The numbers change considerably when we move to different bases. You know, 3 to the power 1 is 3. 3 to the minus 1 would be 1/3. So if we were asked now for the log of 3 to base 3, we're looking for the power, which is a 1. We're looking for the log of 1/3 to the base 3. We know our answer is minus 1. 3 to the minus 2 is 1 over 3 squared, which is 1 on 9. Now, that might be a number that you wouldn't necessarily associate to base 3, but the log of 1 on 9 to base 3 is negative 2. Of course, then there are the more familiar ones. 3 squared is 9. You could be asked to find the log of 9 to base 3, and that's 2. And log of 27 to base 3. 3 3s are 9, 9 3s are 27. So when we've got a base 3, numbers like 9, 27, 1 on 9, 1 on 27, 1 on 3 are common numbers. Moving on to base 4, 4 2s are 16. We did this one before. Log of 16 to base 4 would be a 2. So when we're talking base 4, 16 is a common number. 5 squared is 25. So log to base 5 of 25 is again 2, the power to which the 5 needs to be raised. 36, that's 1 on 36, isn't it? No, yes, 1 on 36, 1 over 6 squared. So the log to base 6 of this fraction would be negative 2. So what numbers would be associated with base 7? Of course, 49. And the log of 49 to base 7 would be equal to 2. You'll start to pick up connections between the base and the number that you're taking the log of. You wouldn't be asked for the log of 25 to base 4. Not yet. Eventually, yes, but not yet. Because we don't know what to raise 4 to get 25. But you would be asked to find the log of 25 to base 5, because we do know what to raise 5 to in order to get 25. Just being aware of these common powers of some of our smaller numbers is going to be really advantageous. I've said here it is necessary. It really is necessary. It's essential for many questions for you to be able to make the connection between the base, the base of the log, and the number that you're finding the log of. There's got to be a connection. So, when evaluating logs, you can, if they're to base 10, you use your calculator. Or you can think about it without a calculator in this case. The log of 10 to base 10 means what do I raise 10 to in order to get 10? I raise it to the power 1. Just got the calculator up to show you, because I don't know what to raise 10 to get 225. I know 10 squared is 100, but 10 to the power 3 is 1,000. So obviously 225 is between 100 and 1,000, but 2 point what, I don't know. So we can use our calculator. So here on the calculator you can see the log key. This log key is understood to be base 10. So if I want the log, I've pressed log and that's come up, of 225, I can simply press equals and it tells me the answer that you would need to raise 10 to is this 2.352 blah blah. It's saying give the answer here to 2dp, so it's 2.35. Let's have a look at the other log. So clear that. the other log is here, ln, and let me just move this over. Where do we want it? What do we want? The log to base e of the number 3 equals 1.09. Give it to 1 dp, so it's 1.1. And then let's try the log, this one, of this number we know is very close to e, so we're thinking what would you raise e to get e? This 2.7 equals, you almost raise it to 1.99, and to 1 dp that is 1. So it's just giving you an idea that e is this number 2.718, because remember, L to n or log to base e, same notation. Same meaning, different notation. Log to base e or ln. We'll see later a thing called the change of base, and that will be necessary if we need to use the calculator later. But for now, evaluate the log of 9 to base 3. So you know that 9 is 3 squared, so the log is the power. The log to base 2 of 1/8, we know that 1 over 8 is 1 over 2 to the power 3, which is 2 to the minus 3. So the log of 1/8 to base 2 is minus 3. Find x, find the number that you would need to raise 4, when you take 4 and raise it to the power 2, what number do you get? You get 16. Therefore, x is 16. And here we're saying, if I take a and raise it to the power 1, that is x. So what is a? A is equal to x. I think I should stop the video there because we're running out of time before I talk about the log laws.